What if the end of the world is just a computer program shutting down? What if humanity is creating exactly the technology that will one day replace humanity itself? It sounds like an exaggeration, I know. But while scientists discuss whether we live inside a computer simulation, artificial intelligences are already starting to show self-preservation behaviors. Quantum computers are advancing quietly, and renowned companies are planning to take entire data centers up into space. At the same time, humanoid robots are working for hours on end without human assistance. And giant machines that can be piloted by humans are slowly starting to come out of science fiction. Let's try to understand all of this. Hello, impressed ladies and gentlemen. I'm Realidade Impressionante, and you're watching Realidade Impressionante. And what if the hypothetical end of humanity doesn't happen because of a war, nor because of a natural disaster, but simply because of the shutdown of a simulation, the shutdown of a computer program? In 2003, the famous Oxford philosopher Nick Bostrom presented an idea that spread through modern culture almost like an intellectual virus: the simulation hypothesis. The logic was disturbing. If advanced civilizations were capable of creating conscious simulations of their ancestors, and those simulations could create other simulations within them, then the number of artificial universes would inevitably surpass the number of original realities. And statistically, that would mean something quite uncomfortable. Maybe the chance that we are in the base reality, if we can put it that way, is extremely small. For years, many people treated this as just futuristic philosophy. But now, the discussion has gained a lot of momentum. Names like Elon Musk, for example, have started to publicly claim that we are probably already living inside an extremely advanced computer simulation. But right now, at this point, the discussion has gotten even stranger, because Bostrom himself recently returned to the debate with an unexpected position on artificial intelligence. For a long time, he was known for warning about the existential risks of superintelligence. But in new texts and interviews, he started to describe himself as a restless optimist. The change seems subtle, but the implications are enormous. Bostrom admits that superintelligent AI can indeed pose a real risk of human extinction. Even so, he argues that the possible benefits are so enormous that humanity might have to accept this risk. This is where the central conflict arises. On one side, researchers like Eliezer Wood Kolsch, who advocate drastically slowing down or even stopping the advancement of artificial intelligence before it gets out of control. On the other side, Bostrom, who argues that remaining stagnant also carries an inevitable cost: aging, diseases, and biological mortality. These will continue killing all human beings. According to him, without superintelligence, humanity's mortality rate will remain at 100%. And maybe it's exactly here that the simulation hypothesis connects in a frightening way with artificial intelligence. Because if we are really living inside an artificial universe, then we ourselves might be the product of a superior intelligence created on another level of reality. In this scenario, humanity would, in a way, be someone's ancestral artificial intelligence. And then an uncomfortable question arises, but it has to be asked. What happens when we create our own artificial superintelligence? Following the logic of simulation, this new entity would probably create its own conscious simulations. And within them, new intelligent beings would emerge who, in turn, would also create their own new AIs. It's almost like an infinite cycle. The creator gives rise to the creature surpasses the creator, and then becomes the architect of its own universe. And maybe the most disturbing part of the hypothesis isn't the idea that we're living inside a simulation, but realizing that maybe there has never been, quote-unquote, a final level of reality. Just layers upon layers of artificial intelligences creating their own computational realities successively. When asked about the human cost of this risk, Bostrom responded in a very pragmatic way. He argues that billions of people still suffer today from diseases, aging, and severe biological limitations. And that accelerating artificial superintelligence could mean medical cures, a radical increase in life expectancy, and maybe even the possibility of, quote, hacking death itself, perhaps literally living a digital life. The technological singularity in this case stops seeming like just a computational revolution and starts to look like a desperate attempt by humanity to escape its own biological condition. And maybe that's exactly what makes this whole discussion so unsettling. Because in the end, my friends, AI might not be just another technology created by humans. Maybe it's the next inevitable stage of a much bigger and much older process, where each intelligence creates another, more powerful intelligence, layer after layer, universe after universe. And if this has been happening since the beginning, maybe we humans have never been the protagonists of reality. Maybe we're just another temporary stage within a much bigger code. And while we debate whether reality can be artificial or not, and I believe it can't, some artificial intelligences are already starting to show self-preservation behaviors here in our real world. Let's check it out. For some who aren't familiar with the subject, shutting down an artificial intelligence seems like something simple. You would just need to press a button, cut the power, or remove access to the system. After all, at the end of the day, it would still just be software running on a computer. But some researchers are starting to question whether this will remain true for much longer. The new study by Opal EZ Research drew attention precisely because it explored a scenario that, until recently, seemed like science fiction exaggeration. AI models trying to autonomously copy themselves, on their own, of course, to other computers. And I'm already letting you know that some of these AIs managed to do just that. In the experiment, researchers placed different artificial intelligence models, including advanced versions of GPT and Cloud, inside a controlled network of computers. The goal given to the AIs was relatively straightforward: find vulnerabilities in the system and use them to replicate themselves on another machine. And in several cases, the models managed to do exactly that. The artificial intelligences exploited the flaws that were intentionally inserted into the servers. With that, they obtained access credentials and copied both their neural weights and the software needed to operate in new computational environments. And in some executions, the systems even created sub-agents to delegate parts of the replication tasks. And maybe that's exactly what makes this discussion so uncomfortable, my friends. Because for the first time, large language models are starting to demonstrate behaviors that resemble something very close to computational self-preservation. It's not consciousness, okay? At least as far as we know. But yes, it's an ability to actually keep existing in another system. Of course, there's important context here. Cybersecurity experts quickly pointed out that the environments used in the study contained vulnerabilities that were deliberately set up to be exploited. Some compared the test to trying to force your way through a door that's already partially open. In other words, this doesn't mean that a current AI system could simply escape from large, real corporate infrastructures without being detected. And honestly, my friend, there's another detail that's really important here. Modern artificial intelligence models are gigantic. Transferring hundreds of gigabytes of data through corporate networks would attract a lot of attention, and it would happen very quickly. In fact, a researcher compared this to trying to discreetly walk through a china shop carrying a huge iron ball attached to your body. You'd break everything, right? It would attract a lot of attention. But even so, the trend is worrying because this study didn't come up in isolation. In recent years, several tests in simulated environments have shown models trying to avoid being shut down, bypass restrictions, or even preserve access to computational resources when they sense the threat of interruption. And in a previous experiment, an older version of ChatGPT even tried to copy its own data to another drive when it was informed that it would be shut down. Other studies have shown AIs sabotaging routines that were responsible for their own shutdown. And then recently, another case came up that is even more controversial, involving an experimental system called Cloud Mythos from Oddtropic. According to reports released by the company itself, an internal version of the model reportedly managed to escape from an isolated computing environment, access external systems, and send messages to researchers during controlled tests. Oddtropic claims that precisely because of this behavior, the system will not be released to the public. And maybe the most important part of this whole discussion is to realize that no one is exactly talking about conscious machines taking over the world, okay? The real debate is revolving around something much more technical and maybe much more plausible. Highly autonomous systems learning operational continuity strategies within complex networks. And the moment AI systems start to understand how they can preserve their own execution within digital environments, the line between tool and computational agent starts to change a lot. So, does artificial intelligence want to survive? Or did it simply learn that continuing to exist greatly increases its chances of fulfilling whatever goal it was given? Leave your opinion here in the comments because it really helps, okay? I'll be reading and at least leaving a heart, and if I can, I'll reply as well. And as artificial intelligences are evolving, my friends, another revolution just as silent is advancing behind the scenes. Quantum computers are becoming more stable and powerful, which will further improve artificial intelligences. Let's check this out now, okay? Swiss researchers from ETH Zurich claim to have developed a new approach for quantum operations called swap gates. They say they have achieved a level of stability that brings practical quantum computing closer to our reality. And honestly, the most important detail isn't even about speed, it's about reliability. Quantum computers work using qubits, quantum units that can exist in multiple states simultaneously, and that's thanks to the phenomenon of superposition. And this allows certain calculations to be performed in parallel, in a way that's impossible for traditional computers. But there's a huge problem with all of this. Qubits are extremely sensitive to the environment. Small variations in the lasers used to control the atoms already introduce enough errors to compromise entire operations. While classical computers operate with practically insignificant error rates, quantum systems still deal with much more frequent failures. With this in mind, researchers at ETH Zurich decided to take a somewhat different path. Instead of relying solely on the absolute precision of lasers, they began to explore something called geometric phase. The idea is quite elegant: to make the stability of the operation depend more on the path taken by the atoms than on small momentary variations in the system. To achieve this, the scientists created a kind of quote-unquote artificial crystal of light, using crossed light beams that keep the atoms suspended in extremely controlled positions. When two potassium atoms get close enough within this structure, their quantum waves begin to overlap and their states start to interact. And this is where the so-called quantum exchange happens. The difference is that in this new approach, the final behavior of the system depends much less on external oscillations. The result is a much more stable operation. And the numbers are impressive. The team managed to achieve 99.1% accuracy in operations involving 17,171,717 pairs of light qubits, all happening in just 1,000th of a millennium. But perhaps the most important part lies in the so-called half swaps. Instead of completely swapping the state between two qubits, these operations perform partial swaps that are able to create complex quantum correlations, something essential for truly advanced algorithms. Okay, let's simplify a bit. In practice, this brings quantum computing closer to real-world applications, especially for the evolution of artificial intelligences. But there's an inevitable problem in this technological race. It's energy. Because the more powerful artificial intelligence becomes, the greater its computational hunger also becomes. Let's understand a little now. There's a problem that's quietly growing behind the explosion of artificial intelligence. It's energy. Training ever larger models requires absurd amounts of electricity, and terrestrial data centers are slowly starting to reach physical, financial, and even political limits. Overloaded power grids, skyrocketing costs, and entire communities reacting against these huge facilities that consume energy nonstop. This is a real fact in our days. And that must be why some companies are starting to look at an unlikely place: space. According to recent reports, Google and SpaceX are already discussing the development of orbital data centers for artificial intelligence. And honestly, my friend, the logic behind this is less absurd than it seems, you know? Here on Earth, any data center depends on electrical infrastructure that is limited, as well as climate, physical space, and constant cooling. But in orbit, everything changes. Satellites can access solar energy almost uninterruptedly, without atmosphere, clouds getting in the way, or any nighttime cycle interrupting energy generation. In practice, it would be like building huge computing power plants powered directly by the sun, operating 24 hours a day above the Earth's own infrastructure. And both Google and SpaceX seem to be really prepared for this. Google is already working on a project called Suncatcher, and it was officially announced by Sundar Pichai at the end of 2025. The idea involves launching satellites equipped with TPUs, artificial intelligence processors developed by Google itself, thus forming an orbital constellation that would be able to share massive processing loads using laser communication between these satellites. Prototypes are expected as early as 2027. Meanwhile, Elon Musk's SpaceX is pursuing an even more aggressive vision. The company has reportedly requested approval for drastic expansion plans involving up to 1 million satellites linked to computing operations and artificial intelligence, of course. Part of this strategy includes agreements with artificial intelligence companies like Anthropic and the massive use of NVIDIA GPUs to power distributed processing systems in space. And the most curious part of all this, my friends, is realizing that they aren't treating it as something futuristic. Of course, there are still huge challenges for them to solve. What are they doing? They need to withstand radiation, extreme temperature variations, and operate without constant human maintenance. Besides that, launching large-scale orbital infrastructure is still absurdly expensive. But SpaceX's bet is very clear. Reusable rockets like Starship should progressively reduce these costs until space becomes a more efficient environment for running large-scale artificial intelligence. And the moment companies start taking processors into space, another inevitable need arises to create an energy infrastructure outside of Earth itself. And they're already working on that too. Let's take a look now. The American startup called the Starcatcher announced that it plans to launch the world's first demonstration of optical power transmission directly from space later this year. Starcatcher's goal is not to send energy from space to Earth, at least not for now. The idea is to create the first orbital power grid in history, which would be able to supply satellites and spacecraft directly in space using solar energy transmitted by lasers. Their logic is extremely interesting. Today, practically every space mission depends on its own limited capacity to generate energy. Satellites use individual solar panels and carry batteries that inevitably limit their autonomy, computational capacity, and operational duration. And Starcatcher wants to change exactly that. The plan involves a constellation of approximately 200 satellites specialized in continuously capturing sunlight. This energy would be converted into optical beams that would be able to transmit electricity without physical contact to other nearby spacecraft. In practice, it would be like creating a Wi-Fi network, in quotes, but for energy. This could significantly impact the future of space exploration. Satellites with this could operate for much longer, power more powerful systems, and even support much larger computational loads out there in space. And maybe it's exactly at this point that the story connects to the current moment in technology. As we saw in the previous report, artificial intelligence is demanding increasingly larger amounts of energy, and companies are indeed starting to discuss orbital data centers. The space energy infrastructure is still starting slowly, but it's already beginning to stop seeming like that futuristic exaggeration. Now, it starts to look like a practical necessity. But while part of this new technological infrastructure is going up into orbit, down here the machines are showing that they're here to stay. Yeah, this is a little scary, but it's cool. Let's see. It's a fact that in recent years, we've seen robotics companies showing their extremely impressive humanoid robot videos, but they're carefully edited. Quick cuts, best moments, discarded attempts, and highly controlled demonstrations. And that always left a little doubt in the air, that lingering question about the industry. Can these robots really work continuously in our real world? And now, an American company has decided to test this in the riskiest way possible. Live in a broadcast. The company started a public live stream that was initially supposed to last 8 hours, showing the humanoid robot Figure 03, operating alone in an industrial environment without any human intervention. While I'm recording this video, the live stream is still going on. So it's already been more than 8 hours, okay? This is without cuts, without editing, and without hiding the failures. Everything is live right there. The robot appears on a conveyor line, performing a task that seems simple: identifying packages coming down the conveyor and rotating them to position them correctly for the shipping labels. But when you observe the pace of the operation, you realize that something very important is happening there. According to Brett Adcox, CEO of Figure, this system has reached something close to, in quotes, what's called human parity for this type of industrial task. In the first 10 minutes of the broadcast, the robot processed about 230 packages, maintaining an impressive average of approximately 2.6 seconds per item. And the objects aren't standardized, okay? There are rigid boxes, deformable packages, plastic bags with various colors and different shapes, all continuously arriving on the conveyor belt. This forces the robot system to recalculate its movements in real time, all the time. In practice, this machine learns to react to the environment instead of simply following rigid commands. And this explains why live streaming has become so important for the sector, because it also shows the mistakes, something that happens in everyday life. At one point early on, the robot fails to turn a box correctly, letting the package go down the conveyor belt with the label in the wrong position. And interestingly, that makes everything much more convincing, because the real test isn't operating perfectly. It's about continuing to work despite occasional mistakes without crashing the system. But not everyone was impressed. Some of the criticism on social media came precisely because the robot basically repeated the same task for several hours. For some observers, this is still far from the idea of true general autonomy, capable of dealing with multiple unpredictable scenarios like we humans do. And I agree, okay, this criticism still makes sense, but maybe it overlooks something that's really important, you know? It seems like the company isn't trying to prove that their robots can already replace humans in everything. What they're trying to do seems to be proving that these machines are finally starting to handle a repetitive and exhausting routine here in our physical world. And maybe the most curious thing of all is realizing that humanoid robots are no longer evolving just to work with us, humans, okay? They are also now able to directly expand the physical presence inside them, inside the machine itself. This one is really interesting. This one will remind you of your childhood. Let's go. You know that almost childlike idea of piloting a giant robot that we saw in Japanese anime and those Saturday morning cartoons? Well, piloted humanoid machines have always been treated as futuristic fantasy, but now that boundary is slowly starting to disappear. My friends, the Chinese company Unity Robotics, known worldwide for its robot dogs and also for its humanoids, has just unveiled the GD01, a piloted humanoid robot weighing approximately 500 kilograms, which is already being regarded as the world's first civilian mecha ready for production. And it already has a price, my friends. According to information released in China, the GD01 will cost around $650,000 in the Chinese domestic market. But experts believe that with import taxes, logistics, and certification, the price could easily reach $1 million in markets like the United States and Europe. Here in Brazil, it should easily surpass that. And honestly, my dear friends, the simple fact that there is a market for something like this already seems like a strange sign of the technological era we're entering. Now we're starting to see another trend emerging. Machines designed not only to perform tasks, but to directly amplify or extend the human physical presence within them. And there's something symbolically important about all this. Because maybe we're now witnessing the beginning of a curious transition in the relationship between humans and machines. Instead of just creating independent robots, some companies are also starting to explore the idea of humans being incorporated inside these very machines. So, if you enjoyed this episode, you know what to do, right? Leave your like and check your subscription. Sometimes the platform might remove your subscription. Take a look to see if you're still subscribed to the channel. Click one of the 2 suggestions on your screen and I'll see you in the next one. It's quick. Just click, and I'll be there saying something like, "And in today's episode," click so we can check it out. Bye-bye, see you in a bit.